Good. Anyway, shall we start? Chapter 9. Chapter 9. In Chapter 9, we will cover the hypothesis testing. Hypothesis testing. Okay, in Chapter 9, we will learn about the hypothesis testing. And hypothesis testing purpose is clear. We want to conduct the analysis of the scientific analysis to make a conclusion in order to draw the implication. Okay? And technically speaking, hypothesis testing can be used to determine whether a statement about the value of a population parameter should or should not be rejected. Okay? Rejected or not rejected. We have two choices, reject or do not reject. Okay? So as I indicated before, if something is within the confidence interval, we do not reject. However, if some value is outside of the confidence interval, we reject. Okay? So, we usually use the null hypothesis. Null hypothesis is a tentative assumption about the population parameter. Null hypothesis, H null, H4, H null, okay? And alternative hypothesis, HA, is the opposite of what is stated in the null hypothesis. Okay, we will see. Okay, so in order to test the established hypothesis, we can use three approaches in statistics. We can use three approaches in testing the hypothesis. Those three approaches are p-value approach, critical value approach, confidence interval approach. 3. P-value approach. If a hypothesis p-value has less than 5% or 10%, we reject. On the other hand, there is a critical value approach. That is, we call this is a test statistics, and we calculate that this kind of critical values, and if some value, if a hypothesis value is larger than the critical value, okay, we reject. Third, confidence interval approach. We establish that confidence interval, and then we will test it that if a certain hypothesis value is within the confidence interval or outside of the confidence interval. If a hypothesis value is outside of the confidence interval, we reject. Okay? So we will learn about the three different approaches. Okay? In your textbook, the textbook proposes three different approaches. But as a bad professor, forget it. No p-value approach, confidence interval approach, or a critical value approach. Please forget it, because we will use this approach. Okay? Because we will use this approach, forget the p-value approach, critical value approach, or the confidence interval approach, because everything will be in here. X bar, scale, Z, or T, X bar equals something, G or T must be 0, sigma, or S, number of the sample, and in here we need to know the degree of freedom. How we can calculate the degree of freedom? N minus 1. Okay, Jared, why N minus 1?
Bad professor.
Because I'm a bad professor. Okay, so then let's put in here, we can calculate the standard error. Show how we can calculate the standard error when we know the sigma. sigma over square root n. Okay, good. Where is my board? Carry. So how we can calculate how we can calculate standard error if we don't know the sigma? Here, standard error of the sigma unknown s over square root n. Okay, good. Okay, so then we construct a confidence interval here. Okay, this is the confidence interval. Okay, so confidence interval can be calculated marginal error. X bar plus minus marginal error. Okay, good. Let's show how we can calculate the marginal error when we know the sigma. Plus minus z alpha over 2 1 t alpha over 2 multiplied by standard error sigma over square root n sigma over square root n. Okay, so when we know the sigma, Captain, how we can calculate the marginal error when we don't know the sigma? Same. T plus minus T alpha over 2 multiplied by S over square root n. What? T. This T. Sorry. Okay. Yeah, that's it. Sorry. Okay, so that is plus marginal error minus marginal error. Okay, and this must be z alpha over 2 or t alpha over 2 minus z alpha over 2 or minus t alpha over 2. Okay, so we play with this 4 numbers. Okay, so this is our constructed confidence interval. Okay, good. Then let's think about it. P-value approach. P-value approach is if some value is outside of the confidence interval in here or here. Okay, what is happening in the p-value? This is a p alpha over 2, and this must be the p some value. Okay, which p-value, which probability value is larger? This. Okay, because that. Okay, so let's calculate the area. This area must be smaller than the critical p-value, right? So that if p-value is smaller than, p-value is smaller than p alpha over 2, so that this is inside of the confidence interval or outside of the confidence interval? Outside. So that what should we do? Reject or do not reject? Reject. Okay, good. First, this is p-value approach. Second, critical value approach is, okay, so we have this critical value, right? Then we can calculate the critical value of something, x something. Okay, so that if critical value is outside of the confidence interval, what will happen? G and G alpha over 2. Which one is larger? G or G alpha over 2? Which one is okay? So let's see. That's not here. This is minus. Okay. So let's play with the here. Okay. So some value is here. Z is here. Okay. Z is here. Good. And which one is larger? G or Z alpha over 2 or T alpha over 2. Which one is larger? Z and T. Okay. This is larger, right? So if a critical value, Z value or T value is outside of the confidence interval, this critical value must be larger than the critical value of this. Okay? So then, if G or T is larger than the T, Z alpha over 2 or T alpha over 2, we reject. Okay? Good. And third, confidence interval approach. See that p-value or z-value or t-value is within the confidence interval, outside of the confidence interval. If some value is outside of the confidence interval, we reject. Okay, outside. We reject the null hypothesis. Okay? So, no matter what, p-value approach or critical value approach, p-value approach or critical value approach or confidence interval approach, please start with drawing. Okay? That will help you. So, first, try to establish confidence interval based on your interpretation of this. Okay? Then, please see your hypothesis value. Okay? If your hypothesis value, okay, we only use H null. Okay? Okay. If your hypothesis value is here, okay, or here, whatever, okay, this one is not in here. See, if your hypothesis value is outside the confidence interval, you reject the null hypothesis. However, if your hypothesis value is within the confidence interval, we do not reject the null hypothesis. Okay? In the level of certain specific confidence level. Okay? That is how we test the null hypothesis. Okay? So, here, you already know these kind of things. Standard deviation population sigma known. When we know the sigma, and when we have larger than the 30 samples, we can use that standard normal distribution Z. Okay, and then we calculate this. We construct the confidence interval in here and here. When we define the confidence level in here, okay. Then we compare this constructed confidence interval with the proposed null hypothesis. If the null hypothesis is within the confidence interval, we do not reject. If the proposed null hypothesis is outside of our constructed confidence interval, we reject. Okay? So then, this is that. So, sigma known, there are two ways, and unfortunately the textual proposed is that is centered in the hypothesis value. It is centered in the hypothesis value where x bar minus mu null. Mu null is a hypothesis value. So then, textual proposed, you'd better to construct the confidence interval in the center of the null hypothesis. Okay? But don't do that. Please don't do that. Okay? So my proposal is, please use this. Z or T equal mu null minus x bar. X bar is centered in here. X bar. Okay? Because this comes from the sample. Okay? However, hypothesis value can be changed over time or changed according to the situation. But this data will be stable. So then, personally, I propose, please keep consistent. Okay? Establish your confidence interval in the center of the sample mean. Okay? This is that. Z equal mu naught minus x bar over standard error, and the standard deviation sigma, standard deviation of the population sigma unknown. Test statistics must be T, okay, and the T is mu naught minus x bar over standard error of S divided by square root n. We call this is test statistics. Okay, we call that kinds of things as test statistics. Okay, so test statistics can be Z or T. Okay, so then, the textbook proposes that the Z test statistics of G can be centered in the null hypothesis value of the mu naught, but however, personally, I propose that hypothesis value minus x bar centered in the sample mean over standard error, that is mu naught minus x bar over sigma over square root n. When we know the sigma, and the sample size is larger than the 30. Okay, we can use the test statistics of Z like this. Okay, and when we don't know the sigma, and or the sample size is 30, so or smaller than the 30. Okay, absolutely we must use the T statistics, and T statistics can be mu naught minus centered by x bar over standard error is same. And however, mu naught x bar S over square root n. Okay? Good. Okay, so then how we can use this critical value? Z, if the Z null, okay, I will define this is null, okay, because we calculate the deviation from the null hypothesis. G null, absolute value, T null, absolute value, and then we have G alpha over 2 or Z T alpha over 2. Okay, however, we will see this is two-tailed case. However, let's make it general. Okay? What will happen if the G null is larger than the Z alpha over 2? That is inside of the confidence interval, outside of the confidence interval? Outside. Okay? That's outside. In this case, there must be here Z alpha over 2, here, or T alpha over 2 here. If the Z value is outside of something, G null is here, that must be outside. Absolutely, this is larger. This is 1.96, and that must be 3.3. Absolutely, this is larger. In this case, we reject the null hypothesis. Okay. So, however, if you read the textbook carefully, and that's getting more complicated because sometimes they propose a p-value approach. Okay, sometimes they use a critical value approach. Sometimes confidence interval approach. Please don't divide that. Just start with drawing. Okay, that will help you. Draw the confidence interval and then please check it out. My hypothesis value is within the confidence interval, outside the confidence interval. If your hypothesis is outside the confidence interval, p-value must be smaller than the critical p-value, and the T or Z statistics, test statistics will be larger because that is outside. And then please check it out. Your hypothesis value is within the confidence interval or outside of the confidence interval. That will help you. That will help you to avoid any mistake. You will see. Okay? Good. That's it. And the calculation sigma unknown, we will use D statistics. Sigma unknown, we use a T statistics. Population proportion P. P statistics can be P naught minus P bar over standard error, please. Okay, the same. Good. That's it. Okay? And whenever we test a hypothesis, okay, absolutely we are not free from the error. That is the reason why we always start with this. When we want to make a statistical conclusion, we usually start with in 95% of confidence level or in 99% of confidence level, we reject the null hypothesis or we do not reject the null hypothesis. Okay? That is our language. That is how we express our hypothesis test results. Okay? In 99% of confidence level, we may reject the null hypothesis. We do not reject the null hypothesis. That's our language. That's our statistical conclusion. I know this is totally strange. This sounds strange, but however, this is much more scientific conclusion. Okay? Because we have an error range. Error range, we absolutely propose that our error range. Okay, if I say that I have in 95% of the confidence level, that is, I will have 5% of the error. Okay, so that I say that the confidence level or the error range. Okay, and then we usually say do not reject or reject. Okay, that gives us that clearly define the error type. Okay, we will learn about the type 1 error, type 2 error. Okay, in statistical conclusion, we may have a type 1 error, type 2 error. What is the difference? Type 1 error is, if something is true, we must say that is true. For example, Dylan, okay, Dylan is a boy, Dylan is a man. Okay, but if I say Dylan is a woman, okay, and is it true? No, okay, maybe I may say wrong statement. Okay, so then you must say what? You are wrong, okay? Absolutely. So if I must say that Dylan is a boy. However, if I say, okay, Dylan is a girl, I'm wrong. Okay? In that case, you must say you are wrong. However, if you do not say wrong, okay, you commit a type 1 error. If something is right, you must say that is right. But why do you say that is wrong? We call that is a type 1 error. Type 1 error. And there is another type 2 error. Okay? For example, Dylan is a girl. I said. And then what should you say? I must say wrong. Okay? But what if you say that is right? Make an error. Okay? So that we call that is a type 2 error. If something is right, you must say that is right. And if something is wrong, you must say that is wrong. But you can make a mistake. So that if something is true, and however, if I say that is wrong, that is an error, we call that is a type 1 error. However, if something is wrong, I must say that is wrong. But if you say that is correct, that is type 2 error. If something is right, say right. If something is wrong, say wrong. But unfortunately, we make a lot of errors. We will see that. We will see that things, okay? Absolutely. And then there is a type 1 error, type 2 error. Okay, I think that's all. Okay, yeah, that's all. That's all chapter 10. Chapter 9. No. That's all the chapter 9. Oh, that's almost all. Yeah, absolutely. I will go in detail. Well, this is outline of the chapter 9. Okay? That is all. We learn about establishing the hypothesis, and we will learn about how to test that proposed hypothesis by using statistical evidence. That's it. That's chapter 9. Okay? Shall we go further? Shall we go in detail? Okay, yeah, let's go. Long story short, we started the confidence interval and we tested we propose that the hypothesis that is inside of the confidence interval do not reject, outside the confidence interval reject. That's it. Okay, so then let's go. And developing the law and the alternative hypothesis. And then we will learn about the science. Yes, give me a second. Is it working? Okay. Science and the type 1 error and the type 2 error. Population mean, sigma known, and population mean, and estimating the population mean, sigma known, and the population proportion. That's the structure. Good. And everybody know that how we can start, how we can solve our statistical problem. First, start with drawing. Okay. Second, interpret the problem information, and then confidence level as well. Okay. And then please define the problem question. Okay. And third, standardize. Fourth, refer to the table, standard normal distribution table Z or T table. Okay, and then find the answer and draw the implication. That is our general procedures of the statistical problem solving. Say. Lastly, developing the null and the alternative hypothesis. Okay. Billion, where are you? Okay, so I would ask about what would be our profession? Do you remember? After graduate school, our profession is becoming, we are becoming our profession. We are becoming a business problem solver. Okay, so Lilia, how we can solve our business problem? Have you ever learned about how to solve a business problem? How we can solve a business problem? What is the process of the business problem solving? Yeah, we are becoming a business problem solver, and we must know how to solve a business problem. How to solve a business problem? Solve a problem now. How? How we can solve a business problem? And this we know. Okay, we got to know. We are becoming a business problem solver. Okay, that means we are becoming an expert of the business problem solving. And how to solve a business problem? Anybody know that? No? No? That's an increasing value, decreasing cost. Okay, how? How we can solve a problem? No hypothesis. No hypothesis. Yes. This is a general process of business problem solving. Okay? We usually follow these procedures in order to solve a business problem in a scientific way, with rigorous data. Okay? This is a general procedure. This is the general procedures of the business problem solving. First, we start with defining a problem. What is the problem of the problem? This is a really important problem to solve. Okay? In this case, we must think of key decision maker. Who will define the problem? Okay? You are becoming a business problem solver, and however, in order to solve a business problem, you must know what the hell is the business problem. Okay? For example, okay, so there must be a revenue side problem. Okay? The revenue we want to increase the revenue. But is that increasing the revenue is a real problem of a decision maker? CEO, CFO, or employer of yourself? Is it a big problem for your employer or a key decision maker? Many times, no. Many times, no. They don't care about increasing the revenue. But many times they are much more focusing on reducing the costs. On the other hand, a few number of the key decision makers give more attention in increasing revenue rather than decreasing cost. Many of the decision makers, they just want to exercise their power. They have no interest in increasing revenue or decreasing cost. They want to expand their power. So, as a business problem solver, first thing to do is please identify a most critical problem. If you set up a business problem, if you set up a right problem, right question, the other things are quite mechanistic. So, for example, we have these steps, and as a business problem solver, as a business consultant, what is the most time-consuming process out here? This. I spend around 70% of my time to define a problem. Really? As a business consultant, as a business strategy consultant, I spend almost 70% of my product time to define a problem. Once I define a problem, the other things are quite mechanistic. Really? It takes a lot of time. It's most time consuming, it's most difficult process. So far, you never consider about the problem because usually the problem is given to you. Okay, you just need to solve a problem. But why you don't have any problem? You need to define your own problem. Defining a problem is the most time-consuming, most critical, and the most important process. But nobody talks about it. As a business problem solver, we clearly define a business problem. That's the most important skill set for us to solve a business problem. Many times, your client will chill. CEO will chill. Manager will screw up. Okay? And your customers, your client, your customers, your colleagues, they will fuck you up. Really? You need to be very critical. You need to be sharp. You need to be brilliant to identify your problem. Okay? Start with define the problem. And please think of who is the key decision maker. Okay? Don't fight against with your employer. Don't fight against with your manager. Okay? You need to think of the key decision maker who give you a salary. Okay, so once you have a clearly defined problem, then the other things are problem. Yeah, torture. Yeah, torture. Problem. Yeah, what's the problem? Yeah, torture. So how we get solve that problem? Yeah, torture. That's fine. Okay, good. Try to go to the next step. So once we define a problem, we chunk of the problem. We identify a big chunk of the problem, and we must make it disaggregate. Okay? A few number of the disaggregated issues. In this case, you must think of this. Check for missing. 이거야. So what is missing? What is missing? Very missing. Mutually exclusive, collectively exhaustive. Okay, so we need to think of this. Okay, we have a chunk of a problem. This is a problem. However, we cannot solve this problem. Okay, by chunk. In this case, we need to analyze. And that is this. What is the meaning of this? Analyze. Okay? And what is this? Okay, divide. 1, 2, 3. Divide. Mutually divide. Okay? Mutually divide. Okay? And investigate this in detail. This is divide, and then we do some this. Okay? We do the analysis. We conduct analysis. We will see that. Anyway, when we have a chunk of the big problem, we disaggregate the issue that can be addressed in detail. Okay? Divide, we will do something. Okay? When we disaggregate the issues based on the MISI rule, we have items. We have items. Okay? Then, for each item, we can develop a hypothesis for each. No. Okay? For H1, H2, H3, H4. Hypothesis. We develop the hypothesis. Okay? We develop the hypothesis. When we formulate the hypothesis, we think of what is the end product? What do you expect at the end? Okay? We will see. Good. And then we are ready to do something. Okay? Then, first, we conduct a critical analysis. Okay? In order to perform the critical analysis, okay, we collect the data, we mine the data, we screen the data, and we test the hypothesis. Then we can make a conclusion. Okay? Good. In this case, we must think of the 20 rule or 80-20 rule. What is that rule? 80-20, 20-80 rule? Pareto rule. Okay? Because we have many items. Okay? Usually 20 or 30 items. Okay? We cannot address that the 20 or the 30 every single items. We must choose a few number of the most critical items in order to solve a problem with efficiency. Okay? So then we must choose 20% of most critical items. Okay? Absolutely. So then we conduct critical analysis, we find out something. We got information, we got a knowledge, we understand something, and we make a choice of the critical problems. And we get to know something. Then what should we do? We need to synthesize the findings. That means we make a conclusion. We make a statistical conclusion. Okay, good. We need to draw practical implications. We need to draw the practical implication. In that case, we must think of this very simple question. So what? Many times, business consultants or business researchers, they propose, they collect a lot. They find a lot of very interesting things, but also, and they say like this: in order to improve our productivity, we must increase the revenue. In order to improve our profit, we must decrease the cost. What the heck is that? Really? I am asking about how to increase revenue, how to decrease the cost, and then researchers usually say, in order to improve the profit, you must improve the revenue. No, that's what we said to bullshit. That's totally bullshit. But many times, many business consultants and many smart guys, they said so. Especially, usually, economists usually say so. Yeah, in order to become rich, okay, you must make more money and then you must reduce the cost. Everybody can tell them how. And they have a solution. Practical. Implications. What can I do? Action plan. Please don't say about it. Normative answers. No, please. Normative answers. Please don't say anything about the normative answers. You must increase your revenue. You must increase cost, and you must train the employees, and you must educate your people. Don't say that. That's what we call that as a normative. Normative are the two general answers. Don't say if somebody says so, what should I do? I usually torture them, get out, kill them. Really, I do. Yeah, because I'm a bad professor, so I usually make the people cry over it and something. I do. Because if they say bullshit, okay, that's bullshit, yeah. Really? I need your action plan, solution. I need your solution. I need your action plan to solve a problem. That's our business implication. Unfortunately, it is really popular, and many of the stupid researchers, they just conduct a lot of stupid research, and they propose that the normative answer that does not tell anything. Bullshit, garbage. We don't need any more garbage. We have tons of thousand garbages. I don't need that anymore. Get it out. Please bring me up solution, answer, practical implication, action plan. What should I do? Okay? Good! So then we formulated a nice strategy, action plans, solutions. However, we are the business problem solver, not a talker. Execute. In order to execute, what should we do? We must be able to persuade decision maker. Okay? So finally, we must prepare the powerful communication. Powerful communication. What is the meaning of the powerful communication in business? Persuade. Okay, what is the purpose of using the PowerPoint? Why you are using the PowerPoint? Purpose of the PowerPoint, why you are using the PowerPoint? In order to? Communication? No. In business, okay, PowerPoint is a tool for communication. No, bullshit. Persuasion. There is a big difference. Communication and persuasion, I don't know. But from my business experiences, communication is a part of the persuasion. In business, maybe your communication teacher will do not like this. Absolutely. So communication, absolutely. The communication professors will say communication is larger than the persuading something. But for me, as a business problem solver, no. Okay? Because why we are using the PowerPoint? What is the purpose of a PowerPoint? Huh? Explain for what? When you explain somebody, okay, so what do you expect? What behavior do you want to expect when you explain something? Change the behavior. We call that as a learning. Whatever. So why? Because we want to make an influence, or we want to change the behavior of the customers. We want to make something happen. Okay? And we precisely define that kinds of influence, impact as persuasion. If I can persuade somebody without any PowerPoint, Excel, analysis, blah 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 blah, I don't need to use that PowerPoint or anything else. I just persuade the broker. Absolutely. If I can do, I will do that. What is the purpose of the business? What is the purpose of the business? We talk about the basic. What is the purpose of the business? Purpose. Why we make a business? To make money. Okay, in order to make money, we need to increase the revenue. We need to decrease the cost. Okay, so how we can increase the revenue? What is the best way to increase the revenue? We must be able to sell. We want to make her buy my product. Okay, how I can make you buy? Torture? I want to do that. I want to do that. Can I put please. Just buy this. Can I do that? Torture? Can I torture you to buy something? No. Okay, I cannot torture that. Okay, how I can make you influence? How I can make you buy this? I need to. Exactly. Okay, we need to persuade her to buy my product. Okay. However, communication is nothing but a process of the persuasion. We need to be able to persuade. Then please think of the clear and impactful persuasion. I'm a business. What do you expect from the business? Business? We manipulate the person. We manipulate the people. Okay, that is not business. We are business. Unfortunately, we are not journalists. We are not communication. We are not educator. Am I educator? No. I'm a business. I am persuading, I am manipulating, I'm cheating. I'm cheating you. I'm persuading maybe. Okay, so this is the general process of the business problem solving. Okay? And there are a few number of processes, there are a few number of details, something. But however, this is most general business process, business problem solving process that come from the business consulting industry, from McKinsey, Boston Consulting, the Henderson, or the AT Kean, because I come from that industry. This is a general process of the business consulting, business problem solving. Okay? And if you go to the second floor, there is a free space center. In front of the, what is that? In front of the Bloomberg lab, there is a, I made that. Do you know that I made it? A free center, the business research innovation space center. So do you know who made that? Me. I made it. Okay? And there, in the right side, you can see the business problem solving procedure. Who made it? I made it. Anyway. Okay, good. This is a general process of the business problem solving. In here, one of the most important thing is 70% of my time is spent by define the problem. So then, let's see how we can define a problem, vigorously. And this is my example of the Occam's razor. Have you ever heard about the Occam's razor? Occam's razor. Okay, we will see. This is the scientific way to identify a problem, to formulate the most rigorous hypothesis.
Model series from Evaluation. Have you ever wondered why Mark Zuckerberg always wears the same gray t-shirt? Do you remember Steve Jobs' black turtleneck that he used to wear most of the time? Let's explore why these people who can afford anything in the world choose to stick to such simple things. These are the people who run billion-dollar organizations and manage thousands of people, which means every single day they have to make dozens of important decisions. Making decisions is mentally exhausting. It's called decision fatigue, and everyone has a limited quota of willpower for every day. Zuckerberg and Steve Jobs understood this very well, so they did not want to spend their precious quota of willpower on insignificant decisions like what to wear. So does it mean everyone should start wearing the same dress every day? No, that's not the point. Wearing the same attire every day is just an intelligent hack for simplifying life. You can extend this idea to solve important problems in your work and business. Look for ways to simplify life, and that's the insight behind the mental model of Occam's razor. It's named after 14th century English logician William of Ockham. It's an important principle used in logic and problem solving. Occam's razor states that among competing hypotheses, the hypothesis with the fewest assumptions should be selected. In other words, all things being equal, the simplest solution tends to be the best. Warren Buffett supposedly has a too-hard bucket on his desk, and the majority of the ideas that he comes across end up in that too-hard bucket. Buffett's partner Charlie Munger says, "We have a passion for keeping things simple. If something is too hard, we move on to something else. What could be more simple than that?" So how do you implement this mental model in your decision-making process? The first step is to avoid unknowable and unimportant. Where the interest rates are going, what the stock market is going to do next, are all important but unknowable. So avoiding the activities which are heavily influenced by unknowables is an act of simplification. Similarly, before solving any problem, ask if it is worth solving in the first place. Second tip for simplification is focus. Decision making is simpler when you focus on one thing at a time. Human brain is very poor at multitasking, especially when you are working on complicated and unfamiliar tasks. Remember Pareto's principle? 80% of the results come from 20% of the activities. So focus on top 20% activities and deprioritize the bottom 80%. So what does this mental model of Occam's razor mean for an investor? It means one should search for a simpler business that requires fewer assumptions. In investing, you don't get paid anything extra for.
So, Occam's razor is a razor or the knife. Okay, there is a knife. And here is a chunk of a problem. complicated. Here is a business chunk of the problem. Okay? Then what should we do? By using the knife, cut it off. 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 Okay? Then when we reach into a saturation, the problem must be parsimonious, simple. Okay? When we get rid of the unnecessary things, okay, get rid of unnecessary things. Okay, unnecessary things by using the Occam's razor knife. Okay, and then we finally got a few number of the most critical issues. Then we can solve that problem. Okay? Unnecessary things, getting out the unnecessary things is conceptualized as lean system. Lean production was a lean system. Have you ever heard about the lean production system, lean management system? Lean management system. This is one of the most popular management system. Now, lean management system is AKA Toyota production system, whatever. Now, in manufacturing field, almost all the large manufacturing firms use lean production system. What the heck is a lean production system? Get rid of the unnecessary things, and we call that is get rid of the muda. Okay, and then maybe you can read this like this. Can you read this? So this is unnecessary. Okay? Lean management system is nothing but we get rid of the unnecessary things. For example, okay, so what is the example? Okay, so in the bulletin board in the college business, okay, we have a lot of the English department bullet poster something. Is it necessary? I don't think so. So what I do? I get rid of that. Really? And if something is unnecessary, and a few of the stupid communication teachers ask for, the biggest professors must do something for our communication class students. Is it necessary for me? No. Then what I do? I torture the communication teacher. Stop it. I will kill them. So, anytime, if there is any unnecessary things, I kill. I get rid of them. I want to make something simple as possible. Because we believe simple is beautiful. Jason, why your girlfriend is beautiful? Symmetry. Another. Symmetry is beautiful. Another. Simple is beautiful. Make it simple. Okay, don't make it complicated. Okay? Because we are interested in solving problems. We don't want to extrapolating our problems. No. I want to make it simple as possible because I want to solve that problem. Unfortunately, I am interested in it. I told you there is a critiques. Okay, so if we use that Occam's razor a lot, we ignore many. For example, training rule, according to the training rule, okay? So then, we call that as a parsimonious rule something. Simple is beautiful. We use that. That is a parsimonious rule. The simple, the better. Okay, absolutely. And however, in many cases, many critics, many people critique about it. Okay, so business guys, you make a lot of things too simple. Really. And they argue. And usually, so 28 rule, according to our 28 rule, I just focus on the 20% of the problem. And that means I ignore the 80% of unknown something, unnecessary things. And then anybody talks about, okay, so we need to solve the 80% of something. Bullshit, because I want to solve the 80% of the solutions. So, I know we ignore many chunks of the problems because we are selective. We are very selective. Because I want to solve a problem, I know, but I take the risk. Because I want to solve the problem. Make it simple. Okay? Symmetry is beautiful. Show. Simple is beautiful. Okay. Make it simple by using your Occam's razor, Occam's knife. Cut it off. Get rid of the unnecessary things and then bite it up. Please get rid of this Buddha or the Buyong. Okay, get rid of that. Okay, if there is anything unnecessary, yeah. Okay, so then we get an essential problem and then we solve the problem. That is our general procedures of the business problem solving. Why I spend a lot of time to explain this? Because that is our profession. Okay? Statistics is just a small part of this. This is just a small part of this procedure. And this is the general research procedure as well. If you want to find a new knowledge, okay, throughout the research, this is the general procedures of your research. Okay? Good. And once we understand these general procedures of the problem solving, we can go forward to the quantitative analysis. Technically speaking, statistics is a tool to do this. Very small. Statistics is used for here. Small part of the business problem solving is statistics. And more specifically speaking, quantitative analysis technique. Okay? And however, there is a qualitative data analysis or a qualitative problem solving, and then there is another experimental, and there is integrative. There are tons of thousands different ways of addressing our hypothesis. We are learning about a very small part of the statistics. Anyway, this is a nice start. Okay, good. And developing the null and the alternative hypothesis. Unfortunately, there is no golden rule in setting up a hypothesis. So there is no golden rule. It depends on your choice. And there is art. Formulating a hypothesis is art, scientific art. Okay, so it is not always obvious how the alternative hypothesis should be formulated. We don't have a clear scientific something. Okay, it depends. Care must be taken to structure the hypothesis appropriately so that the test conclusion provided the information the research why earned. That means we must be very careful. We must be considerate to formulate the hypothesis. The context of the situation is very important. First thing to do is try to understand the background of the problem. Contextual knowledge is very necessary. In determining how the hypothesis usually stated, in some cases it is easier to identify alternative hypothesis first. In other cases, not is easier. Okay? Now the correct hypothesis formulation will take practice. That means we need a lot of practice. It's an art. To master that, it takes time. However, okay, and alternative hypothesis, the research hypothesis, many applications of the hypothesis has been working on them to gather the evidence in supporting of research hypothesis. In such case, it is often best to give the alternative hypothesis to make it something. And the conclusion that the research hypothesis is true is made if the sample data provided sufficient evidence to show that the null hypothesis can be rejected. We will see. Okay, good. And here is an example. Here's an example. There is a fact. And something is happened. Something has happened. And a new teaching method is developed. For example, online learning, online teaching. Okay? So that we did online classes a few tweaks around in the first. Okay? And our new online class is better than the offline course, offline teaching, offline class or not? No. That's inverted. When I collect the data, okay, so survey, the students' satisfaction survey, okay, opposite. Really, many students give a higher mark than the offline. Online class is much better than the offline class. Really? Is it true? No? I have a data. I have a data. I tested the object power. I found it. Error? No. That is true. Why that happens? Why students get happier when we provided the online course? Because teachers, instructors give a better score, better GPA. No? So how we can interpret that? Should we go to online or offline? Okay, according to our evidence, in order to make our students happier, we must go to the online. Does it make sense? I don't think so. We need more study. Okay? Like this. Many things are totally bingo. Many things are context. We need to understand about the contextual understandings. Even though we have data, even though we have understanding, even though we have numbers, okay, we must ask this. So what? Should we go to the online? Does it make sense? I don't think so. Saying, a new teaching method is developed, online course is developed that is believed to be better than the current method, current offline. Okay? So that I want to test it. I want to test something. Alternative hypothesis is supporting this argument. This is argument. Statement. Okay? This is argument or this is a statement. Okay? Then alternative means the new teaching method is better. That is a supporting this. Okay? However, null hypothesis means negative. No. Not. Okay? What is the meaning of the null? Null is zero or no, not, negative. So, negative means this is the new method is no better than the old method. So then, what hypothesis I may test? Null hypothesis. Okay, good. And then second example is new Salesforce bonus plan. New Salesforce bonus plan is developed in an attempt to increase sales. If we apply that the new bonus plan, we can increase the revenue. Okay? Then alternative supporting, and so new bonus plan increases revenue. Good. Alternative. Null hypothesis, no. The new bonus plan does not increase the sales. Okay? The null hypothesis, please nature contains no, negative, nothing. No. Okay. In number 3, the new drop is developed with the goal to lower the blood pressure more than the existing drop. Okay, new drop lowers the blood pressure more than the existing drop. No hypothesis, no new drop does not lower blood pressure more than the existing drop. No, negative, no, zero, no, not. Okay. No hypothesis, by nature, it contains no. Then we might begin with a belief that the assumption that a statement about that the value of the population parameter is true. That means our parameter is here, within here. We believe. Okay? And we then use the hypothesis to challenge the assumption and determine if there is a statistical evidence to conclude the assumption is incorrect. Reject or do not reject. We will test. In this situation itself, to develop a null hypothesis first. Okay, for example, what is that? Okay, so online class is bad. Okay, so I want to test, I want to collect the data and then to prove, okay, the online class is better or the offline class is better for our students. I want to test. I will collect the data. In this case, okay, and then I can formulate the hypothesis. Null hypothesis is online course does not better than the previous offline class. That's a null, not, okay? And the alternative hypothesis must be online class is better than the offline class. Okay, I formulate that. So then, what should I do? Okay, so for example, I use the null hypothesis. For example, online class does not better than offline class. Okay, so what will happen if I reject that? So then what will happen? What does that mean? If I reject the null hypothesis, online class is better. Okay? So that if I reject the null hypothesis, I can strongly support my alternative hypothesis. Okay? This is an opposite. It's problem of the logics. Logical thinking, critical reasoning. Okay? It's a logic problem. So if you want to say something true, we better to reject the null hypothesis. Okay? Because that is much more safe to minimize the risk of error. Okay? And we will go forward about the type 1 error and type 2 error to understand the error. And okay, good. And so far, that is that. Null hypothesis. Okay, and then we will see that null hypothesis, and then we will talk about the 1-tail test or 2-tail test tomorrow. Tomorrow. Okay. And then we will go. Okay, so let me use it. Okay, so then, this is the general procedures of the business problem solving by using the hypothesis. Any question so far? Okay. And from tomorrow, we will go forward about how we can use the data, the statistical data, to perform or reject the hypothesis. Good.